All right, so as you can probably tell, they misspelled my my presentation on the little handout we have here. It's not collected and graphite, unfortunately. So I'm going to talk about collecting graphite. There are a couple of ways to kind of pull data from Postgres and then display it in a nice way that makes it handy for consumption by more than just you. My name, as Magnus pointed out, is Shaun Thomas. I've been working exclusively with Postgres since 2005. I kind of dabbled in 2001 when it was junk, so I threw it away. I feel really bad about that, so I apologize. And then just recently, they've published a book that I was working on for a few months called the Postgres 9 High Availability Cookbook. Not so wild about the title, but I've heard it's okay. Actually, there's a copy of the book that I've given to the committee for putting into the auction. I've kind of made a paragraph of stuff, and then I signed it. So if that's something you'd be interested in, there's a copy available. So why graphical monitors? The main reason that I tend to use them is I'm not really a visual learner, but at the same time, being able to just look at something and know pretty much immediately what could be in your short list of things that could be wrong is really handy. You also obviously can watch for trends. You can go back several days, weeks, whatever, however long you've had this stuff set up. And if you really want to focus on those, you can usually zoom in on a certain degree to see if things were the same way, several weeks ago. The stack we're going to be using is Collect D and Graphite. Pretty simple, not a lot going on there. And I'm going to go into a little bit more of what you can do with it later, kind of just on the side. Not really on the slides, but there's some other things you can do with these things because of the way they're built. So why Collect D? I'm going to have a kind of a graph of how it works in a minute, but essentially it's a distributed system for pulling in data from lots of different things. It operates very similarly to a cluster where you have like a client-server kind of setup. And it makes it really easy to kind of put the client on all the servers you want to monitor and then have them just broadcast to some central core, and it just collects all the stats for display later. And it's customizable, and by that I mean it has all the plugins in the universe. It's got plugins for output, input, sideways, dimensional extracts. It's got everything. It makes it handy to kind of get the formats you want. And if you really want to, you can write your own plugins. So that's why it's handy also. But obviously, that's all right there. So here's a little more in-depth as to what Collect D actually looks like. It looks all right up there. I can't really blow it up, unfortunately. But like I said, if you've got, say, a cluster of Postgres servers, you can set them all up to send to one central core system. This makes it very easy to set up if you've got like a configuration management system, like a bconfig or Chef or Puppet or Ansible or Salt, something like that where you just want to set a standard configuration for your Postgres clients and you want to monitor them all with the same recipe. So again, the plugins. The part that really comes down to, though, why I use, say, Collect D instead of something like StatsD or some other kind of stats-related system is the Postgres plugin for Collect D lets you write arbitrary queries, and you can pull the columns in any way you really want. So you can monitor customer activity, you can monitor Postgres stats, you can pretty much look at any kind of thing you want to actually watch on a long-term basis and turn it into some kind of graph without having to like hack your application or put in monitors or put in taps. You can just query it every once in a while as long as you have the data available. And the granularity that it offers, you can actually set it up to, again, with configuration management systems, you can do it up to a database level, or just do it on every database on the system if you just, it'll do that all based on the output of your queries. So if you know how to kind of fork that into there, you can do that too. So why Graphite on top of the Collect D? Why Graphite? Well, graphs, obviously. They're handy to have. No, okay, you can also save graphs. It's handy because if you're putting everything into a single interface, you want to be able to obviously save all the pointing and clicking you've done up until that point. And oddly enough, that's not always a feature of the monitoring tools and dashboards I've seen, which is kind of strange. And of course, dashboards, because you can't have monitoring without a dashboard. Yeah, so this is going to be in part of the actual demonstration. I'm going to actually go through and build like a quick little graph in the default Graphite installation I have on my system. And you can ask, instead of just putting all the different graphing points on the same graph, you can also apply transformations. Like you say you want a standard deviation, you want a mean, you want a median, you want to do a derivative or an integral. You can do all of that in the data as it's on the graph, and it'll actually display that live with the other streams you have. So it makes it easy to do more complicated trends than just the output that you're getting from your queries. And probably the most important point about Graphite are these last 2 points. It has an API for both receiving and sending data, making it not just a display system or kind of a dashboard. It's actually more of a middleware. You can send data to it, and you can pull data from it. And you can, if you don't like the way Graphite displays something, or if you don't like, or you want to use the data somewhere else in some other manner, you can actually use its API to pull that information out. So it acts as an aggregation level even beyond the collectee stuff. So if you have other types of data entry points, they can also send to Graphite, and it will make those available to anything downstream if you want to pull those from the API. And that's the other major reason that I've seen that system administrators and infrastructure groups are using Graphite, because they can plug it into stuff like Graylog or some other kind of major tool that can pull the information for better aggregation in some kind of format they're more accustomed to. So before I really get into any of this, just when you're doing monitoring, have a separate monitor user. I've seen a few systems where they don't do that, and it's just risky. Don't do it, please. Have a user specifically for monitoring. Set it up in your PGHBA-conf, whatever. Just make sure that that's all it can do is monitor. Don't make it a super user. User grants. Be nice. So as far as installing it goes, it's just basic pull the tarball, make install. Why didn't I use, say, like a package manager system like through Red Hat or apt, like if you're using Yum or whatever? There's a bit of a bug in earlier versions of collectd that caused it to segfault anytime you set up more than one database in the Postgres plugin. They've since fixed that, but there's a risk you could get the older version that causes that problem. So I'm just going to use the source version. And I suggest doing that at least until, if it's anything before 5.4.0, use the source. So the other thing that I like to suggest people do when they set up a collectd instance is to split the configuration into 4 separate files. Did I actually do this right? Yeah. So of the 4 files, the first one is just the basic configuration file that gets collectd up and running. Just set up the basic stuff, PID file, logging, your network configuration, basically those other 2 configuration files that were in this list to be included. I'm just logging to syslog. You don't have to. You can also log to a log file if you want. That's in my liner notes, which will be in the PDF version that I put on the wiki page later today. So that'll all be there in case you want to read through my liner notes and the discussions of the slides. That's all going to be available to anyone who wants to get those. So let's see here. The other thing is for the Networkcom file, like I said, this is a client-server-based model. So you're going to want to have 2 of those, one on the client servers, on the Postgres servers, and one on your aggregator node for collecting all the monitor statistics. So on the Postgres nodes, all you got to say is the server I'm sending the data to, and assuming PG monitor monitoring system, and the default port is 25826, so I decided to use that. And that's basically what all of your network.conf files will look like on all your Postgres nodes. It'll just say where to send the data, and you don't have to worry about anything else. And on your aggregator, of course, you've got listen on this time I'm just listening on all interfaces, which you probably shouldn't do, but this is just a demonstration, so who cares? And it basically just sits around waiting for data to get collected to it. Pretty easy, not anything really complicated. So here's how the local conf I've kind of suggested setting up. It has two jobs. One is to kind of discuss what the local system does. In this case, it's including the Postgres config file to make it, so that's the file that's going to have all your Postgres queries and databases defined, as far as using the Postgres plugin. That tells you, obviously, that this is a Postgres node. And if you're on the aggregator node, you're going to actually have the Graphite plugin configured instead, because its local job is to talk to Graphite. It collects data from all the remote nodes and then sends it to Graphite. Right now, that's its only job. And that's really all I've used it for personally. And really what it comes down to there is you've got to set up the prefix, because that tells it does a couple of things. If you set up the prefix, you can actually, in Graphite, you can actually drill down to the specific data source. In this case, it would be collect D, so you can easily find it. And it also makes it so you can set up different data rules for how long it should keep data and how granular it should be when it finally starts rolling it into an RRD style save file. Graphite saves data by default in a format called Whisper, which is basically kind of like RRD. So you've got you can get really high level granularity for a day, then kind of lower granularity for like a week, and then even lower granularity for a month, and so on. And you can actually have different granularity levels defined for each data source. So in this case, having the prefix as collectD lets us target that for a specific set of granularity settings. So this is basically what a Postgres plugin will look like. You load the plugin, and in your sudo XML, it's not really XML obviously, because you've got bare keywords in the middle of the data. But basically you can set as many queries as you want in the little query blocks, and you can set as many databases as you want in the database section. The query sections come in several parts. You've got your select statement, and then your result definition. So you basically have to say, of the select statement, there are three basic types in Graphite. There's derive, there's, I can't remember them. But we'll get to that later. There's the three types of the graphing points basically decide how to display your graphs. Because in Postgres, a lot of the stats are cumulative. They just keep rising, and you need to get the difference between them. In this case, the derive type, that's what it does. So it basically, every single data point you send it, it assumes the previous data point was a previous data point. So it subtracts the two, and that way you get a continuous graph without having to make your own kind of sub-level where you do like 2 queries and then subtract the 2. It'll do all that for you. So you can just write a basic query and get the output, and you don't have to sit there and format it to the thing you're sending it to, which is very, very handy. The values from part is where you define which column has the data for the result type you have here. So for the result type, each result type you define is a separate data stream that can be turned into a graph item. And in this case, the select statement, which is not shown, at least not in this slide, the column in this case was called TPS for transactions per second, and then that's the data type that is being pulled from the query. So say I had that query, the TPS thing, and I wanted to run it in the default Postgres database that's installed on every system that we get at the very beginning. Then I would just set up a database. You set the host user password is optional. Obviously, you can use PGPass files or local auth or some kind of setup to pass that through. Don't worry about that too much. But what I'd like to point out is the instance keyword. So if you have a system where you have your database is named the same everywhere you go, you've got say your database is just called production. In this case, it's Postgres. So your database is called Postgres, and you've got one in production, you've got one in stage, you've got one in development, you've got one in integration testing, well, you can actually label all of these with the instance kind of what its target demographic is, and that will be in the drill down, so you can actually look at which target without having to worry about the database name changing underneath you. You don't have to prefix it or anything, it's just going to be part of the drill down. It's a very handy kind of feature that they put into the Postgres plugin. So once it's installed, there's actually a directory in the collectd system that has, and I was actually surprised at this, it has startup scripts for pretty much everything. It's got an upstart script, it's got an initd script, it's got systemd. So if you want to use one of those and not have to worry about starting collectd, then those are all there. And obviously in the book, I also included one that I wrote that kind of removes itself from the arbitrary nature of the Red Hat or Debian kind of style, because Red Hat has its own self-defined functions that you've got to use for the init script to work, and Debian has, it uses like start, stop, daemon, which Red Hat doesn't have. So if you want an init script that works on both, you kind of have to have a third party provide it, and I did. I'm not sure if the code is available without buying the book, but if it's not, then it's not a very complicated script. So I could cut and paste that too if you want an email. So Graphite itself is a bit of a beast to get going. It's a Django project, which Django has kind of a reputation of deprecating things a lot and breaking between versions. And it also uses a lot of Python dependencies, which use other Python dependencies, which use other Python dependencies, and it's just a version hell. So I'm going to kind of, my slides kind of go through the installation process and simplify it a lot, so it's not quite as bad. But that's neither here nor there. You can generally install it on the same node as you have the aggregator node with collectd, or like I said, since collectd can send wherever the Graphite installation is on another server. Now, one of the reasons you might want to separate the two is probably due to system overhead. So collectd is launching all these, well, it's not launching all these, it's getting data from all these different systems, and it's got to write to either to the disk or to another Graphite system remotely. So depending on how many CPUs you've got and how much overhead there is, you might need to split the two systems apart, and you can do that. But by default, just put it on the aggregator node, and if you need to split them apart, you can later. So installing Graphite includes a heck of a lot of prerequisites and dependencies. If you're using Red Hat, there's you basically need the pip stuff, Django, Cairo, and Python devel. And obviously in Debian, the package names are slightly different, but you need to start off with those before you really do anything else, because they're all integral into how collectd and Graphite will work. And Graphite won't run without them, so I guess there's that too. If you run a Red Hat system, there's a third-party repository that keeps track of some of these more esoteric system packages, like the Cairo and Django ones I think are only available through the EPEL repository. So I would suggest using that if you don't already. I don't think I've actually ever seen a Red Hat or CentOS system that doesn't have EPEL at least set up as a tertiary repository. So once you get those prerequisites, you need more prerequisites. This is all the stuff you need to install using pip, the Python package installer for the pipey stuff. And you'll probably notice that I set twisted equals to 11.1 specifically for the Carbon install. Carbon is actually how Graphite collects the data. It's the daemon that runs on a port and actually listens for data to be sent to Graphite. So the twisted version that they expect is older than the one that's actually the main new version on Pipey. And the version on Pipey breaks a lot of stuff, so again, you've got to target specific versions, and this is why I included this, because if you don't, it won't work. The other issue is the book was published somehow, and that double equal sign was turned into a single equal sign, which is a syntax error. So I figured if I make that really public, everyone will know that they need to put that extra equal sign in, because I don't think it's, the book's only been out for a month, so producing errata at this point is probably a little premature. And then Whisper, like I said before, is the default mechanism for saving the data. So you gotta obviously install that. Once it's installed, you got to configure it, obviously. And that usually boils down to just moving the default files into what their expected names would be. And in a Django project, you need to have a local settings Python file so that it knows how to set the secret key and any database configuration options you want to do if you want the metadata to be in like Postgres or MySQL or something instead of SQLite, which is the default. And Graphite has metadata because it keeps your, like I said, the configuration of your graphs, the users that you're configured to log in with, and like everything else is all metadata that it keeps locally. And by default, that's SQLite. If anything in local settings you want to change, it's all there. And that's why the example file I've just moved over, so you can just look at the settings you want to change. They're all commented out, so not a big deal. And then you just start it. By syncing it, you basically create the SQLite database that it wants by default for saving all the metadata. Or if you set up the configuration stuff to use some other tertiary database, it'll sync all that and create all the data structures and fill them with default fixture data and get it ready for running. The other thing you need to do is configure, like I said, Carbon, which is how it pulls the data, how it collects the data from all the other tertiary data sources. And then the storage schemas.conf I mentioned because that file is actually how you define all the separate granularities of how you want the Whisper files to be saved. So remember how I said that you have really high granularity for like a day, and then you can kind of split it up after that. Well, this file, storageschemas.conf, is where those are defined. So you obviously need to have a copy of that available. The defaults, again, are not right, which is why we tweak them. At the beginning, the very beginning of the storage schemas file, you need to put this block or something similar to it, because Graphite actually applies them in the order they're defined, not based on which match works better. So here's the problem with that. If you put this at the end, the default is to give you, I think it's 1 minute granularity for a day, and then nothing else. So, I mean, if you try to look at data that's more than a day old, you'll get a blank graph every single time. So what I've done with this particular configuration, the default polling interval for a collectee client is every 10 seconds. So every 10 seconds it's going to, unless you override it, it'll run your queries and send them off to the aggregator. The pattern that I set up for this to kind of make it easier to, I guess, keep track of and give a good default, a better default granularity is, one day you get 10-second granularity. For a month you get, or sorry, for 7 days you get 1 minute granularity. For a month you get 5 minute granularity. So it's slowly degrading, but it's not to the point where it's unusable. And then for your 1 year graphs, you have 1 hour summaries. So it's, you can extend these as much as you want. Just keep in mind that the more data points you put in here, the bigger those Whisper files are going to get, since they're kind of a rotating data file structure. I think this particular format gives us maybe 128K per file, which isn't bad. But I've seen a couple of defaults that we set up on our infrastructure team. They wanted 1 second granularity for the first week. And those files ended up being something like half a meg apiece. So, when you have like thousands of those, that builds up, and your storage mechanism can't really keep up with it. So that's another thing to keep in mind. Whatever granularity level you choose, all of your collectee data is going to be coming in with that granularity. Every single data point, like every time I set one of those database TPS or whatever graph points, that's a whole data point. Anything that collectee sends to Graphite will be another data point. Those will build up to a point where if it's not properly managed or configured, your storage could fall over. So that's something you'll want to watch, at least on a monitoring server that saves the Whisper files to disk. So that might be something you want to add to the monitor. Put it on your graph and see the percent utilization fly up and then stay that way.
When it's summarizing from one granularity to the next, can you choose whether it uses average, min, or max?
Maybe. I'm not entirely certain. I do know that Whisper is its own format because the makers of Graphite weren't really happy with how RRD worked. as far as how you could set the mins, maxes, whatever. So it's possible there are ways to kind of tweak how it does that. I think it averages, because if you go back and look at some of my older graphs for the week-old data, the higher graphs clearly sync. They're not maxing. I'm pretty sure it's averaging. No, so that's a good question. Oh, sorry, I didn't see you. I can't see through the light. Yeah?
You said that it runs those regular expressions in order of the file, right?
Yeah.
So could you have like the first pattern being collect the.production and have a tighter retention schedule?
Oh, yeah, yeah. You could totally do that.
And just let all the rest of them default to some.
Yep, that's a good idea. Like, obviously, this pattern just matches all of collect D, and I just have the same granularity for everything. But you could totally set it up so that like the default is less granular than this, and then like for production, you like spread it out a lot more. That's completely a capability that it could do. And that's, I mean, it's just a regular expression, and it's not really a big deal. So yeah, that's actually a good point that I wouldn't have thought of myself. So in order to start Graphite, you need to start both parts of it. So your Carbon cache is where it actually pulls in the data and then like kind of feeds it to the Whisper files. And then Graphite is the GUI front end to kind of make it available for everyone. And that's always handy. Once you start those two, you can put that in your own startup script. I'm not sure I wrote one for the book. I probably did, but again, you have to start two things, not just one. You got to start the Carbon cache and collect D as a web service. And the thing is, because it's a Django application, you can start it up, and then since it's supposed to be done with a proxy. Like you're supposed to set it up with like some kind of Python web server, or set it up through Apache to work as a proxy. And then you're not supposed to expose it directly like I am now. Like that will actually run it as a web server of its own. Like it'll be running a Python web server, and it'll be serving the results directly. It's fine for like internal use probably, but I wouldn't recommend it for general consumption for like a larger group of more than just like infrastructure and development. Like if you're trying to do this for use for wider distribution, probably want to set up an actual web Apache proxy. So this is the query that I kind of had removed from that thing so it would fit on the slide. This is my TPS query. No, I'm lying. I'm getting to the point where I'm doing other queries, because apparently I didn't have a slide for the TPS query. So other things you can do other than transactions per second, which you can get from the pgstat database table. You can get stuff like inserts or updates or deletes per second. Graphite and collect.d both know the default resolution is 10 seconds, so they divide the difference between the two measurements by 10, so you're actually getting a rough estimate of per second. So in this case, it's just a couple summaries of the different things from one of the stat tables in Postgres. Replication, again, is just a query. And this particular query, I know it's ugly, but it actually basically turns, if you run this on a replication node for a Postgres streaming replica, it'll basically tell you how many seconds behind it is the master. So that's one thing you can monitor on the replication nodes, and then put that in the same, you could put all those in the same graph. So you can see, like, make a general replication lag graph of all your different nodes, and you can actually see, like, have a line for each one of them, see how far behind they are of the main system. That actually works, obviously, anywhere you have a replica, so it would work with chaining replication. We've only used it for the main nodes that we have, but you can pretty much use it any way you want. And again, I'm just kind of showing here how you can put any query you want into this thing, and it'll work, assuming you pull out the data points. In this case, time lag would be my column that I'd be trying to pull out for a data point. And then this gross query, you probably can tell what it's doing. I'm getting the idle and I'm turning the pgstats activity table into something more consumable. Like I'm pulling out like how many connections are idle in transaction, which is really important if you're trying to figure out if there's lots of things blocking deployments or things that are blocking other things. It's usually something is stuck in a transaction. It happens all the time. Even our automated systems somehow will get stuck. Like a Java thing just like breaks, falls over, leaves its connection open while it's in a transaction. Suddenly you can't get anything done that it was working on at the time. So knowing that there's more than like a few of those is easy to, it helps find out. And you can actually watch the trends. So if you know that, like say a certain time of night, you've got a job that's running, and you can see that number of idle transactions climb, well, it's blocking something that's going on there, and you can use that to investigate. You can see your active queries. So like in our system, there's usually about 80 or 90 active like queries at any one time when you check this. So on the system that I'm monitoring, we handle about 2 billion queries a day, and that's roughly at 15,000 transactions per second while it's happening. And being able to see like the actual volume is coming from like maybe 60 or 70 Postgres clients, that tells us what the ideal pool size could be if we decided to set up a pooling system. So you can get a lot of information from these graphs just by looking at the summaries from simple queries like this. I mean, this is a simple query, honestly. Like this, it fits on a slide. Any query that fits on a slide is a simple query, right? So, I mean, I could have written a query like this, and actually I do have one that tells me like all the locks, what they lock, what they're blocking, and it just goes on and on for stuff like that. And it goes on for like 3 or 4 pages. For those, I would suggest making a view and then selecting from the view into your stats, but I mean, it makes it also easier. So, because the thing is, you notice these backslashes. That's because you can't have new lines in collect D syntax. So you've got to escape them if you want your query to be human readable. And I kind of like looking through the config files occasionally to make sure like the query's right. And you can't really do that if it's all just one giant long line, especially if it's a query like this where you've got 10 lines of query to read through. Oh, yeah.
So for this example, can you send basically multiple stats back in a single query?
Yeah, actually, I will show the full version of this query definition block in a minute. Because like these are all different stat points. You'll notice that trans idle is a separate column from active, which is a separate column from waiting, which is a separate column from, those are all separate data points, but they're all from the same query. And you can pull those independently and label them as separate data points, which will then be consumed by collectd and sent to Graphite. But I'll show how to break that down in a minute, because that's in my liner notes, because it's way, way too long to show on a slide, unfortunately. Before I get to demo, I think I'll even just show you that. This is the liner notes, which I can generate pretty much whenever. So the query that I was just showing you, I don't know if you can see that. Yeah. So this section here was the query. And then down here, you're actually defining all of the data points. So like the gauge, what a gauge type in Graphite is basically the derive does a diff between the 2 data points. The gauge assumes it's an absolute value. So in the case where I'm doing summaries of things from pgstat activity, that's what I'd want, because it's anytime you look at it, it's just going to give you the absolute numbers because it's on a per client basis. So in this case, all these gauges, I have a prefix so I can differentiate them from other things. So like I have my total clients, total idle clients, total transaction idles. Like these are all separate data points that are being pulled from this single query. And you can do that as many times as you want. You can even put the same data point in there multiple times if you really want to, just name different things. I wouldn't really suggest that, but there could be a use case that I haven't thought of. So I want to go to the demo real quick. I've got actually a Graphite that's running on my local system. That's the dashboard. So here's the local Graphite. And I'm going to just grab a arbitrary data point. How about the number of, actually I don't want that one. Let's go with rows inserted. And let me change my, to the last, I don't know, hour. So I've actually got a script running in the background running pgbench in various capacities. So you'll see that the stats kind of vary on a kind of a heartbeat kind of structure. Let me zoom in even further to get the last 15 minutes. So that makes it a little more obvious what's going on. But the whole point of this is you can kind of combine as many graph data points as you want. I just put in the updates, right? And if I really wanted to, I could also put in the row exclusive locks. They're kind of going to be this little red dip down here. But you can combine graphs of any kind of style you want, and that makes it really easy to pull them out. The other thing that's handy that lets you do is you can actually, like I said, you can do the transformations. It's like, here's all these calculations. There's all those. And you can change the legend names, because honestly, that whole path is kind of irritating. So let's see, which one was that? So now it's just updates, because I don't want to see, collect D, Babbage, Postgres production, derive, rows inserted is kind of irritating to look at on your chart there. So there's lots of different things you can do with this. But among them, you can also save kind of graphs you've made earlier. So here's one that's probably not very useful. Let's talk about locks. So when I'm running my background process, it's obviously locking stuff as it's doing the updates. So I can see that. And obviously, I changed my background to black, and I've labeled the graph to be lock summary, and I've kind of changed all these legend systems so they're actually readable. But these are, again, all saved. Anyone who can log into to Graphite can do this. And this particular graph I pulled out specifically because you'll notice this blue line here. That's actually a chart that I've put in where I'm doing a moving average of the last 10 data points. So you'll notice that because of the fact that this is a script running in the background, it's got a heartbeat, which is now being kind of removed by the leading average. So you can actually see that the average rough number of queries per second my laptop is handling is around 5,000. So that's kind of one of the things you can use it for is applying post data point calculations, and Graphite does that for you. You don't have to put that in your Postgres query. You don't have to use window functions. Well, you could, but you don't have to. And finally, the dashboard system. So when you first get to the dashboard, you see this. It's empty. There's nothing here, unless I don't erase the stupid thing. Take the demo dashboard off. So this is the dashboard thing you'll get if you just click on the dashboard icon, empty. But if you go to the Finder, you can actually save as many dashboards as you want. So I'll just go to the Finder. I've only saved my demo dashboard, so that's all that's there. And you'll notice that I've got some of the 4 graphs that I've already saved, which you can do with graph, new graph, from saved graph, if you want to. And there's my transactions per second with the average line through it. The database write activity, like all these are here, and you can add as many of these as you can stand. And I've got it set to auto refresh, blah, blah, blah. And then you can change the size if you want to squeeze more in there. Let's do 300. So like if you want to I wouldn't suggest it that small, but you can see what I'm doing here. You can actually squeeze as many graphs on here as you can stand that are actually readable. And our infrastructure team has done exactly that. It's kind of actually funny seeing all the different graphs they've got on their dashboard. They've got 30 or 40 per system. They've got several tabs so they can switch between them. But that's basically collecting Graphite in a nutshell. Nothing crazy, nothing annoying. And like I said, the reason we use it is, again, because it's middleware. And one of the things that our infrastructure team has done is Grafana, I had mentioned it in an earlier slide, is kind of like a Java front-end thing you can put onto it, and it actually uses jQuery to pull from the API I was mentioning before from Graphite, and using nothing but JavaScript, it actually builds a much nicer looking interface with, you can zoom in on your data points, and because the things you have in here you can't. I can't actually zoom. It's just an image that it's generating and putting on your screen. So the JavaScript one, though, can. You can do a little more zooming. You can actually hover over these data points and actually get what the value is instead of just having to figure out what it is over here. So that's one front end to Graphite that's available. There's more than just that one. That's just a really popular one because it's one of the first, and it looks really nice, so we use it. But there's the fact that this is middleware is what makes that possible, and that's one of the reasons that I kind of advocate the use of Graphite and Collect D, because they're only as limiting as you want them to be, because you can plug anything on top or in between, or after, before, whatever you want or can. It took me a while to find this dashboard. And what's really funny about this story is I was actually trying to find a way to graph the Postgres database, and so was separately, our infrastructure team was trying to graph their own stuff. And they had separately, independently, also decided that Graphite was the way they wanted to graph all their incoming system graphs. Not collectd, they decided some other tool would be better to feed the Graphite data. I think they were sending some kind of export from Nagios, or CheckMK was exporting to Graphite, which also is another option. You can, like I said, you can pull data from anywhere. I'm just using collectd because it's a way to write arbitrary queries that with a heartbeat, they can send data to Graphite. So there's more links in here about where to get all this stuff and how to read the documentation, and especially in the case of Graphite and collectd, setting up like the plugins and getting it so that it looks right. And that takes a little bit of a fine-toothed comb to kind of make sure you've got the right syntax and the right kind of output format, and you've got the right summary versions of like your aggregates so that they look okay in a graph. It takes a little bit of playing around, but you can get it pretty easily. And like I said, installing it, I wouldn't say it's completely simple, but as long as you have a good step-by-step thing to just cut and paste, it'll kind of do it all for you. The only caveat that I have is if you have a newer version of Ubuntu or Debian or anything like that, the version of Graphite that's in the repositories the version of Graphite that's available right now from the Pipey repo is dependent on a version of Django that's no longer current. So it depends on Django 1.5, and 1.7 is, I think it's out now. So if you try to run that on a newer system, it will not work because they've deprecated several of the Python exports. So what will end up happening is you'll get like an export error, and you'll get internal server errors every time you try to load the page. So try to, if you have Graphite, you want to get this running, make sure you have Django 1.5 or below. 1.6 and 1.7 will not work unless you actually go to the friggin' Graphite site and download their patched, up-to-date version. The one on Pipey is not new enough to include those changes, which I apologize for, but it's not my problem, so. But I did, kind of by guilt by association, because I'm like, I'll use this tool, it's awesome if you can install it. So, questions, comments, hate mail, whatever. Yeah.
Can you use someone else's Graphite server?
Yeah. Assuming you can actually get to the API call, it's basically just an HTTP call. So like I said, jQuery can contact it. As long as there's a hole for the data to be displayed, you can get to it.
I meant maybe from a commercial point of view, are there any recommended?
Oh, like a commercial Graphite server? I don't know. There probably is. I don't know of any, but I didn't really look. So I think you had your hand up.
Yeah, one of the things that we do is someone will poke around and build a graph and find some correlation, and they'll want to share it.
Mm-hmm.
And I know you can just copy the URL or send a URL. Can you demo that?
Yeah, I think. So my dashboard. Actually, I'll just get this graph. So.
Like right-click
Right-click on the graph and do copy
image
image
URL
URL.
and load
You
that up.
can email that, or you can go to your dashboard and do graph from URL.
Yeah, there you go.
So that's always really handy. And then one other thing you can do here is just on the end of that URL, do and format equals JSON, and this will poop out JSON.
Yeah, so that's actually one of the ways the API was pulling it for probably the jQuery stuff. So, I mean, this is, again, like I said, it's basically a middleware with a very simple API. I mean, it's just JSON export, so. But yeah, I probably should have had a slide for that, sorry. Yeah?
So what kind of hardware would you recommend for this? If you get it to do, a VM?
You know,
VM's going to get over,
yeah, it really depends on how many nodes you have. So like in the case of collectd, one of the reasons I gave a very simple configuration file that's stripped down, the default collectd configuration file has like 30 or 40 plugins enabled. A lot of them like for watching disk stats and system stats, and like just, it's basically meant to monitor your entire system. I've torn out all of that and made it just monitor Postgres. Obviously, you don't have to go that far, but depending on how many points you export, that's going to obviously put a strain on the monitor server. So I would just, I would start with a basic, 64 gigs of RAM, a RAID 10 of like 10 disks. Disk is probably fine to start with. And if you need more than that, I would just add more as you watch the system get more and more beat down. We're doing fine with just that basic install, and we have something like 300 or 400 nodes. So we're doing okay with that. But it is kind of starting to put some strain on the SAN, I have to admit. At least that's what the infrastructure team says.
But no VM, so you would not recommend VM then?
Not for, if it's an adequately equipped VM, you can. But you would need to have, have it pretty well equipped, like, maybe a dozen processors, 16 gigs of RAM or more. Yeah. Well, no, I've seen VMs that are like bigger than our main database server. So, I think you.
Yeah, do you have any comment about like Collective versus Diamond at our office where we're running everything via Diamond?
I'm not familiar with Diamond. Is that a new? Because when I was looking, there was actually I've based this chapter in the book. This is actually half of chapter 5. I'm actually presenting on. I based all that on several web pages and blog posts I saw up to when I wrote that section. So if it's newer or just wasn't as popular, I probably missed it in my search. Oh yeah, like I want to search for diamond. Oh, geez. Like generic word, like Google's Go language. Like how do you even find that? Like, I guess you can type Golang, and that seems to work these days. But like initially, I'm like, how do you even search for Go?
I just searched for Graphite, and the first thing that came up with this Graphite.
That's odd because like Graphite, it's probably because you're a dev, so all of your history, it knows you're not looking for pencils. Would you have your hand up, Nasby, or just okay? Anyone else?
Does Graphite make possible to show like same sample from multiple origin systems in the same graph without special collection to make that possible?
Same sample from multiple systems.
Show me the live statement count for these 4 boxes in one graph.
Oh yeah.
Line by timestamp or whatever.
I mean, like I said, when I clicked on those graphs initially, let's go back to my. So let's just reload this and clear that out. I only have the one source, but like I said, you can put as many of these graphs you want on here. You can do it multiple times. So like the way I did the graph for the saved data is I started off with TPS pgbench, and then I did it again. Not that way, obviously. Let's go to my data points. Okay, so TPS pgbench for this one point. This is for the production. It actually keeps the entire path. So you'll notice the path here. So like if you did this for multiple systems, say I wanted stage and QA and dev and QA and whatever, those would all be separate paths. So they all be separate data points. I mean, there's still TPS pgbench graphs, but they would be, the path would be different, so they would be considered separate entries. And the other thing is when I've got this guy here and I say apply, say I want to change the legend name to foo, whatever. Now when I add another one, it's a separate line. And that's how I did the, say I wanted to apply my moving average. I want, say, the last 5 data points instead of the last 10. And that's how that line shows up. Let me get the last hour again. So, like, as you can see, like, you can combine as many lines you want. As long as the path is different, it shows up as a new line on the graph.
I think you can use an asterisk or something in there to kind of magically.
So if you've got them all hierarchically defined, you could just say, production dot splat dot.
I think.
Show me all my production machines.
Yeah, so like just take off the last key and fill it with a star, and I think you'll get.
So I think if I had multiple instances, it would be this.
Sure.
So that seems to work.
And if you took off the last key, then you could see all your measurements for production on one.
I wouldn't do that though because, yeah, like all the scales are completely different, so you'd end up with like this a mess.
Yes,
A
but you
lot
can.
of times that's very useful because you can do that like, I know in Diamond we have stats on almost every table, so if you want to look at who's getting slammed by hits or whatever because you're having a plan change, you can do that to do the most deviant function and say, show me the 5 or 10 most deviant ones.
Yeah, and actually I do have in our own system, I have one that gives us the top 10 most active tables for the day. And unfortunately, because of those are always changing, I can't alias them. So I get the whole path, which is kind of irritating. But you still get to see, like, you can highlight which one, and you'll be able to tell, like, the green one is, your accounts table or whatever. Yeah. So.
And Grafana, once you get the graph here, putting it into Grafana makes it a whole lot easier to read because
You can actually hover over whatever and get.
Which one is the green one?
Yeah. Oh, okay. Well, I guess that's it then.